We previously learned that refraction occurs when light bends from one medium to another, and it occurs specifically when we're talking about two transparent media, when our index of refraction is different for the two media, and when the angle of incidence is greater than 0 degrees. This video will talk about a law called Snell's law, which will cover the math that can be used to predict at exactly what angle a beam of light will bend when we know the index of refraction of the two media it is traveling between. Snell's law, as you can see here, goes with the equation n1 sine theta 1 equals n2 sine theta 2. In this particular equation, the n1 is the index of refraction for the material that the light is in when it makes the angle theta 1 with the normal. N2 is the index of refraction for the material the light is in when it makes the angle theta 2 with the normal. Again, as we've already learned, that all angles must be measured with respect to the normal. And often we can talk about this with saying that N1 might be the first material, the first medium that the light is in. So we could say that theta 1 would be the angle of incidence, and N2 might be the second material, and theta 2 would be the angle of refraction. An important reminder here is to make sure that your calculator is in degree mode. This is important because our angles will be in degrees, and so we need to make sure we tell our calculator that that's the unit we're working in. If we're thinking about kind of some concepts and being able to predict which way the light will bend, if we have light traveling from an index of refraction with traveling from a medium with a lower index of refraction to a medium with a higher index of refraction, then you'll notice that the light bends toward the normal, or we could say that theta 2 is less than theta 1. If instead we're going from a medium with a higher index of refraction to one with a lower index of refraction, then our angle of incidence is less than our angle of refraction, or theta 1 is less than theta 2. We'll use these ideas to not only make calculations of unknown angles or unknown indices of refraction, but then we'll also use these ideas to be able to argue which way light will bend in several different scenarios.